My talk is about location insights for your graphs with Neo4j, PostGIS, and Brickgraph. I'm also going to touch a little bit on some agentic things, which is great that we're following that previous talk because a lot of that was about building agents. So we'll talk about that a little bit as well. So in terms of the agenda, going to talk a little bit about why and when to incorporate geospatial analytics, why location is relevant or might be something to consider for your use cases, your businesses, your projects, how location actually fits really nicely alongside graph databases. Graphs are kind of a map in a way, and so there's a lot of synergy and they complement each other very well. And then I'll touch on operationalizing geospatial insights into your agent pipeline, kind of introducing this concept we call internally GeoGraph RAG, kind of extending graph RAG that obviously has been extremely hyped and successful, particularly in the Neo4j community, and adding a geospatial component to that. And touch a little bit about Brickgraph and how this platform brings it all together. Got a few resources as well. I can share a link to the presentation perhaps near the end of the chat or near the end of the talk, but some links to various things that I'll touch on during the presentation. Before I get into it, I want to kind of go to the end and show a little bit of sort of what we are building internally at Brickgraph and sort of how location analytics fits into this agentic tool that we've incorporated into our product. So what you're seeing here is our new tool, Kensington, which allows folks to chat with their graph within Brickgraph, but also to perform geospatial analytics. So what you're seeing here is a pretty classic graph RAG, a graph RAG approach, pulling in the context from the graph around a property, its associated leases, tenants, etc. And now Kensington will perform a radius travel time analysis, basically a drive time demographic breakdown that factors in the location of that initial property that was searched in the first question. So really the takeaway from all of this is that we're trying to build an agent that can chain graph RAG with geospatial analytics in a very seamless experience for the user so that you can easily move between graph insights and geospatial insights and integrate them together for use cases where it might be relevant. So that's the finish line. And then, starting at the beginning is really about when and why to incorporate geospatial analytics and tools. Location analytics are really powerful for revealing patterns that might be invisible in traditional data analysis. Some estimates are that up to 80% of enterprise data has a location component, but isn't being analyzed within a geographic context. And much like graphs, location reveals relationships, so proximity, clustering, et cetera, that can be really useful and powerful for operational efficiency, strategic decision-making. The four kind of main categories of using location analytics are here: pattern detection, optimization, decision support, and predictive modeling. So the pattern detection, really when you're trying to find clustering of events or locations, think examples of demand hotspots, service gaps, risk concentrations. These come up in lots of different domains, but really being able to visualize data in space helps to identify where patterns are emerging. Optimization. So this has been used in transportation and logistics, since the beginning around reducing costs through route optimization. In real estate, we talk about facility placement, design. Decision support, so things like tracking assets, monitoring field operations, changing conditions, particularly when you get into things like weather and geography. Predictive modeling, forecasting demand, risk, behaviors, adding this additional context and data on locations can really help you get in front of potential changes in your specific domain. Examples here around footfall traffic for retail, et cetera. So specific use cases, location analytics, of course, is used in network and territory optimization. So trying to understand where the optimal boundaries are for sales territory, service areas, of course, logistics, network planning. anything that involves distributed resources or coverage areas, location analytics are going to help you make better decisions. Risk assessment, resource allocation. So think insurance underwriting, emergency response planning, which has actually come up a few times with some Brickgraph customers and users. So where risk or demand is going to vary by location for any number of factors, integrating location analytics can be very helpful. Customer asset movement, delivery optimization, obviously really important nowadays, customer journey mapping, and anything that involves geographically targeted operations. So agriculture, energy, sustainability domains, urban planning, obviously a major one. So where the observations are really based on the location. In our specific domain, real estate investment and development, we look at things like portfolio planning and asset management. Where are things located? Site selection for potential opportunities, property risk and sustainability, reporting and insights for stakeholders. This is actually a way that we integrate data from our graph with location analytics to kind of bring a more fulsome picture for stakeholders who, maybe they're investors or potentially they're community partners. There's lots of ways that we can bring that together for the real estate investment development world. The truth is, location analytics has historically been pretty challenging. It's time consuming, it's expensive, it's highly specialized. But this talk is about how there are some really exciting emerging tools and tools that have been around for a while, but are now becoming, more available to everyday developers. And specifically, we want to talk about PostGIS. So anyone who's been used relational databases and Postgres may be familiar with the ecosystem of extensions that are available to the Postgres relational database, and PostGIS is one of those. So it extends the capabilities of Postgres, adding support for storing, indexing, querying geospatial data specifically. At a basic level, it allows you to create columns of geospatial data predominantly using what's called well-known text. We won't necessarily get into that, but that's functionally how it works. There's a collection of features that PostGIS offers, but I want to highlight these three in particular. Spatial data storage, so the ability to store these different types of spatial data, points, lines, polygons, to be used for spatial search. Spatial indexing allows you to quickly search and retrieve the spatial index, and the spatial functions that are built into PostGIS allow you to execute operations to find or combine or query the data itself. Of course, my fire alarm is now going off. So apologies for that. I'm just going to give that a few seconds to pause. It's great timing. Great. Sorry about that. So if we move on from PostGIS overview into the advantages of PostGIS, so it has really great performance and scale. You can query millions of geometries. Process does these operations on the database server, so you're not using resources on the application layer. And it can handle some significantly, it's quite large data sets that might be too large for your desktop GIS tools. Because it's part of the Postgres kind of infrastructure, Postgres ecosystem, it's relatively straightforward for enterprise integration because it works within the standard database workflows. It's open source and it has an extensive function library, so you've really got a lot of options in terms of trying things out before you get into commercial options. And it's quite developer friendly because of its SQL-based syntax, and it integrates with standard application frameworks and ORMs. So we actually at Brickgraph do use a supported Postgres instance in Supabase, and we use SQL model as our object relational model, or ORM. You can use raw SQL for working with PostGIS, but we like SQL model just because of the type safety, and it's part of kind of the fast API Pydantic ecosystem. So how do you integrate it with your Neo4j graph database? Really, we take a pretty straightforward approach. And in our backend, we concurrently manage location in Neo4j and PostGIS by making just some simple modifications to our CRUD functions. So this allows for best fit retrieval operations. So we can, based on what the use case or the user need, we can retrieve either from the graph or from PostGIS. And so it gives us a lot of flexibility to do multiple retrieval options. And so we've added a step in our create, update, and delete functions. where Neo4j gets the graph objects and PostGIS gets vector embedding and geometry. Just a quick note on the vector embedding, we also use the PG vector extension in Postgres, so we can actually have PostGIS and PG vector right next to each other. So that means that we can do semantic embeddings in PostGIS. You can do this in Neo4j, of course. This is just a design choice, but you can easily do the vector embedding on the Neo4j side as well. But this gives us a couple more interesting retrieval options, namely semantic and geospatial search. As I mentioned, for Brickgraph, we use SQL Model ORM. Again, largely because of the we use Fast API for our backend. At the end of the presentation, I've got some links to that. So if you want to check out SQL Model, I do recommend it. It's a great open source package. This is an example of a Python function for PostGIS embedding. So you can see relatively straightforward. We do a multi-tenant architecture in Neo4j. So we do have org UIDs, and then you pass the data. We created a function to prepare the embedding for storage, and that returns a label, vectors, and coordinates. And then this PostGIS embedding object is a SQL model object that, so we can create this object by passing these parameters, which includes the coordinates as well as the vector embeddings. And then we simply add it to the session, commit it, and that will add a row in our database. And as you can see, we can pass the session right through the function. So this is how we process the graph object for storage in our PostGIS database. So how do we sort of build this in for retrieval purposes so that we can get that sort of integrated agentic flow? So simple search and retrieval, a user may ask a question like, can I see properties near Boston? So we can geocode the address using a geocoding service. In our case, we use Mapbox, extract the latitude, longitude. We pass that in a payload to a function called getEntitiesByArea, which does the PostGIS retrieval. It adds a buffer, which basically is, think of it as a circular area, a radius around that given point. It executes typically a k-nearest search to find locations that are within that buffer area, returns the data from the database, and then we process it through Fast API with the type validation from Pydantic, and then it's sent as JSON via our API. So really simple, just geocode, execute the function, return the result, and then you've got something pretty powerful for your users without actually very complex amount of code or too many steps. So this is the function. This is the other side of it. This is retrieving PostGIS. So you can see all you have to do is pass the latitude and longitude. We pass a buffer distance in meters. I am based in Boston, but I am Canadian and live in the UK, hence the meters. And then we execute this search with a PostGIS session. You can see right there, the starting point, that's going to create the point. This is st set srid is actually built into PostGIS. That's one of those functions. So that's creating a point. And then in the statement, we're using SQL Model if this isn't totally familiar, but you can use raw SQL here as well. But in this select statement in the where function, what it's doing is it's creating that buffer using another of the PostGIS built-in functions, dwithin, which is just creating an area that we can use for search of our points. Executes it, and then that will return any of the entities from that area. So complex search and retrieval would be something along the lines of a user asking, analyze our Boston property. And the first step there, we would do a semantic search for Boston property, which is stored again as a vector in our PostGIS PG vector database. This step can be done in Neo4j, but we do it in Postgres. We're extracting the coordinates and the UUID of the returned row. And then we do two concurrent steps. One is to pass the coordinates to a travel time analysis service. The other is to execute a graph, a Cypher query to get object data and relationships via Neo4j. Then we can put those things together as context to be passed to the LLM. And that's basically the agent flow at a pretty high level. And so how do we bring this together with Brickgraph? First of all, what is Brickgraph? It's a no-code geospatial knowledge graph with 4 core features. The first feature is a data model or ontology builder. So you can see in this first photo here, what we're doing is actually building the schema right in Brickgraph. So you can see this is an ontology for a real estate investment firm. That not everything in this ontology is going to have a location component, but things like properties, opportunities, demises, potentially even tenants, they will. And so we can create a location as a field. We have an address field type. We can also create the data itself, which we can visualize as a subgraph. So you're seeing here an example of Arendelle, which is a property, and you can see that it's owned by Metropolitan, so on and so forth. This is totally familiar to anyone who's been using Neo4j, but Brickgraph allows you to do that right in the platform and then pass that to our mapping feature, which allows you to do this travel time analysis. So we're trying to put those pieces together. And then the fourth core feature is our new graph RAG agent called Kensington, which kind of wraps that whole process together in an agent, in a conversational flow. And so this is an example. This is if you were listening to or watching William Lyon's presentation just before mine. He spent his focus was on agents, which was really great. I was watching it, and he gave a much better breakdown of what tools are and how tools are used inside of agents. This is an example of an agent tool for location search and travel time analysis using Pydantic AI. So if anyone is a Python developer, Pydantic is a framework for building agents, somewhat similar to LangChain, just has a somewhat different ergonomics. Same people who built Pydantic, the typing library for Python. So what you're seeing here, and there's just a few things I'll point out. This is a typical Python function, typically an async function, and it'll return a tool return object. And this is important because if you'll notice, the tool return allows you to pass metadata and as well as a return value. So the return value of this function will be passed as context to the LLM, but the metadata will be passed separately. So what that means is that we can execute tool calling within our agent that will return the response that we want to go to the LLM in its loop, as well as metadata, which will be returned separately as structured data that we can work with, typically for visualization or for returning structured data, which is exactly how we use Pydantic AI in the Kensington flow. So when you put these tools together, that was just one example of a travel time analysis, but when we put it together in Kensington, the agent, using Pydantic AI, we're instantiating this agent class, give it a name, we add a model, or in this case, we're using Anthropic's Claude Sonnet 4, but you can swap those out rather easily. And then we give a collection of tools. There's a fair bit of parameters that you can add, but for the purposes of this, we've just given it the function and the name. And you'll see, the travel time analysis, we can give it different names. And these tools will actually return that response as well as the metadata. And what we sort of end up with once we pass this to the front end, we instantiate this in Fast API as our backend, and in our front end, what we end up with is something where we can visualize both the LLM response here on the left, as well as the structured data from the travel time analysis function here on the right. And so we can visualize the data that we're returning in a map. We can also instruct the model to return a detailed response alongside a summary response. So a lot of flexibility there to create agents that surface artifacts that are grounded in real data, and the functions that you would use throughout the app. So the radius search is actually something that you can do directly inside of Brickgraph, and we're now surfacing it through Kensington because of the way that we've been able to structure the agent. So I'll revisit this now that we have kind of gone through this cycle again, and so you can see how what this first question is about graph context. And so this is that. Please go to Neo4j, return my data, package it up. We can also reference the data that we're returning because of the way that Pydantic works. And then now to revisit, now we're going to run this travel time analysis, and it's going to give us the data that we were looking for. So we're a tad early, but you can see, basically what it's doing. But I did want to touch a little bit on some of the resources that we chatted about today. So if you're interested at all in Brickgraph, please feel free to reach out or send us a note. PostGIS is open source. It's available as an extension in any hosted Postgres service, I believe. Again, we use Supabase. It's very easy to set up. It really doesn't take any time at all. You just apply the extension in your Supabase instance. SQL model is, as I mentioned, ORM. It combines SQL Alchemy and Pydantic, so it's quite useful for type safety when working with SQL. It allows for a lot of really good control if you're doing a lot of things in SQL, and it does have features for PostGIS or working with geometry data. Fast API, we didn't really touch on too much, but it is the framework that we use in Python. It combines Starlet and Pydantic, so adds type safety in if you're using REST APIs. Pydantic AI is the agent framework. I know that this conference will talk a lot about agent frameworks. Pydantic AI will probably come up a few times, but it's one that we use and frankly really love. So just released, I think, version 1. So definitely check that out if you're interested in agent frameworks in Python. And then Mapbox we use for our visualizations and geocoding and isochrones. I will leave it there in the interest of potentially opening it up to any questions. If anyone has any